Okay, this is Go Math Lesson 9.2 on expressions and equations, 6.EE.9. So this lesson's on equations and tables. The essential question is, how can you translate between equations and tables? So when an equation describes a relationship between two quantities, the variable x often represents the independent variable, and y often represents the dependent variable. A value of the independent variable is called the input value, and a value of the dependent variable is called the output value. And so they show you an example here. So the equation is y equals x plus 3. And so if the input is 2, you're going to substitute a 2 where the x is. So 2 plus 3 equals 5. And so then your output y is 5. Then they show you another example right here. Same equation, y equals x plus 3. The input is 4, so you're going to substitute the 4 where the x is. And then 4 plus 3 equals 7, so y equals 7, so your output is 7. So here's a real world problem. A skating rink charges $3 for each hour of skating plus $1.75 to rent skates. Write an equation for the relationship that gives the total cost y in dollars for skating x hours. Then make a table that shows the cost of skating for 1, 2, 3, and 4 hours. So write an equation for the relationship and use the equation to make a table. So right here it says, what is the independent variable and what is the dependent variable? So the time in hours would be your independent variable, and that's going to be my x. And then the total cost in dollars is going to be my y, which is my dependent variable. So then I'm going to come down here and write my equation. So my total cost, this is my dependent variable, y is equal to $3, 3 for each, just multiply. Hour is going to be my independent variable, which in this case it's x, plus $1.75. $1.75 is for the rental of the skates. So my equation, the equation for the relationship is y equals 3x plus 175. So then I'm going to use that to figure out what it would cost for 1 hour, 2 hours, 3 hours, and 4 hours. So they already did 1 hour for us. So you're going to substitute in the number of hours for the x. So they did 3 times 1, which would be 3, plus $1.75 is $4.75. Now I'm going to do the same thing, but I'm going to substitute in the 2 for 2 hours. So it's going to be 3 times 2 plus $1.75. So 3 times 2 is 6 plus $1.75 is $7.75. Now I'm going to do the same thing for 3 hours. 3 times 3 plus $1.75. So 3 times 3 is 9 plus $1.75 is $10.75. Now I'm going to do the same thing for 4 hours. 3 times 4 plus $1.75. So 3 times 4 is 12 plus $1.75 is $13.75. Okay. Another example, it says Jamal downloads songs on his MP3 player. The table shows how the time it takes him to download a song depends on the song's file size. Write an equation for the relationship shown in the table. Then use the equation to find how many seconds it takes Jamal to download a song with a file size of 7 megabytes. So it says write an equation. So you have to look for a pattern between the file sizes and the download times. It has to be the same pattern all the way through. So they tried 12 times 4. And when you go 12 times 4, you get 48. Well, then the rule has to be the same all the way across. So then they're like, is 12 times 5 60? Yes. And then you're going to do it to the next one. 12 times 6. Does that equal 72? Yes. So this rule is looking correct. So now you're going to go 12 times 8, which is 96. So it says, now think the download time is going to be your dependent variable y is 12 multiplied by your file size, which is your independent variable, which is x. So my equation is going to be y equals 12x. Now I'm going to use this to find my unknown value for 7. So it says step 2, use the equation to find the download time for a file size of 7 megabytes. So my equation is y equals 12x. Then I'm going to replace my x with 7. So 12 times 7. So 7 times 2 is 14. And it's going to be 84. So it takes Jamal 84 seconds to download a 7 megabyte song. And then this just says, think you can find each download time by multiplying the file size by 12. So question number 1, explain how you can check that your equation for the relationship is correct. So you can check that the equation gives the correct output value for each input value in the table. So the rule just has to be true for every single input value. Question 2, describe a situation in which it would be more useful to represent a relationship between two quantities with an equation than with a table of values. And so that would be true when you want to be able to find the value of the dependent variable, the output, for any value of the independent variable, the input. So if it's not just a few things, you're going to want to use an equation and not a table. So we'll do a few more together. So it says use the equation to complete the table. And so this is my equation, y equals x plus 3. And they're telling me my input is 6. So here's my equation. It's x plus 3. I'm going to substitute in a 6 for my x, and then I'm going to get my output. So 6 plus 3 is 9. Then I'm going to do the same thing, but my input is going to be 8. So it's going to be 8 plus 3. And then I'm going to do the same thing for 10. So it's going to be 10 plus 3. My input's 10, and my output will be 13. I'm going to do this one more problem over here, number 2. My equation now is y equals 2x plus 1. So this first part is going to be 2 times 4 plus 1. So that's going to be 8 plus 1 is 9. So my output will be 9. Now I'm going to do my input as 7. So it's going to be 2 times 7 plus 1. So that would be 14 plus 1 is 15. Now I'm going to do the same thing with my input being 10. 2 times 10 plus 1. So it's going to be 20 plus 1 is 21. If you have any questions, you can ask me on the Google Classroom.